Welcome to the debate. Today we're diving deep into the monumental logistical engine that powered the Old Kingdom, what historians often call the living pyramid. Our subject is the just mind-bending scale required to build something like Khufu's Great Pyramid. We are discussing a single project that consumed over 2.5 million cubic meters of stone.
And if you translate that volume into a daily requirement, based on the estimated 23-year reign, the builders had to quarry, move, and place roughly 340 stone blocks every single day.
It's an incredible number.
To put that in perspective, that means the site operated at a pace of one new stone block set into place approximately every 2 minutes, 12 hours a day, year-round, for 2 decades. It is a stunning, almost unbelievable feat of production.
Exactly, and that sheer scale, that speed, is what drives our central question today. How did the ancient Egyptian state manage this? Was this rapid, colossal construction achieved through a hyper-centralized system defined by sophisticated logistical efficiency and, a robust permanent infrastructure?
Or was it primarily a triumph of raw organizational power, one reliant on the rapid mobilization of massive temporary labor forces using simpler, high-momentum methods?
I'll be arguing that the evidence points overwhelmingly to a high-efficiency, permanent logistical infrastructure underpinning the entire state operation.
And I'll contend that while the organization was certainly centralized, the astonishing pace required forced the system to rely on raw effort and the social genius of mass mobilization, often sacrificing technical elegance for sheer production momentum.
The successful realization of Khufu's complex, and really the Giza Plateau as a whole, it required statecraft that transcended temporary, short-term management. We have to look past the construction workers themselves and examine the systems that were supporting them. This was a long-term, specialized operation built upon robust, permanent infrastructure. The logistical blueprint, it began far from the plateau itself. Consider the sourcing. While the bulk of the 2.5 million cubic meters of core stone came from that massive local quarry, the finest material, the estimated, 67,000 cubic meters of fine white limestone casing, that had to be transported across the Nile from the distant quarries at Tura.
Right.
To manage that kind of cross-river volume, it necessitated sophisticated logistical planning, leveraging the annual flood cycle, the Nile's flow, in requiring purpose-built docking facilities. Furthermore, these facilities were connected to the plateau by massive permanent public works. The causeways, like Khufu's, which we believe ran for nearly 1 kilometer, were not just temporary construction roads. They were elaborate, enduring structures connecting the plateau directly to specialized harbors or lakes engineered specifically for material delivery. This demonstrates a massive, premeditated architectural blueprint, integrating the construction site with the entire regional infrastructure, not just a simple temporary camp. And finally, the social footprint confirms this institutional permanence. Excavations at the plateau's foot reveal the presence of a vast, highly planned settlement, a proto-city, really, with centralized provision facilities. We have evidence of enormous, specialized industrial installations, notably bakeries and fish processing areas, designed to process a staggering volume of loaves and fishes, starch and protein, to sustain this massive workforce over 2 decades. This implies sustained, centralized, and efficient institutional control.
I agree completely on the scale of organization required simply to coordinate people and resources. That's undeniable state power. However, the required daily production rate, those 340 blocks per day, it suggests that the organizational genius was focused on overcoming friction and simply moving stone fast rather than perfecting elaborate engineering efficiencies. To maintain that astonishing rate, 1 block set every 2 minutes, practical constraints must have been overcome using high-momentum, simple methods. Let's look at the primary logistical hurdle, stone elevation. The necessary geometry to lift blocks to the top of Khufu's 146-meter height implies a reliance on ramps. Now, if those ramps were conventional, theoretical models suggest they would require material volumes approaching or even exceeding the volume of the pyramid itself. So this means the methods for ramp building must have been vastly simplified, temporary, and focused on rapid construction and removal. emphasizing practicality over permanent engineering. To maintain that astonishing rate, one block set every 2 minutes, practical constraints must have been overcome using high-momentum, simple methods. Let's look at the primary logistical hurdle. We know from physics that moving the average 2.5-ton core block required about 7.5 men just to overcome static friction on a level, lubricated surface. Now, extrapolate that across the entire operation. Imagine coordinating 2,500 men just to move a daily delivery volume of 340 blocks up a ramp every single day. The focus of the Egyptian administration, therefore, centered around organizing people for maximum raw output. And the labor model supports this. Workers were organized into distinct, often competing gangs like the famous Friends of Menkaure, and they served in rapid, short, rotational shifts of only 2 to 4 months. This was a monumental logistical feat centered entirely on the rapid, high-intensity deployment of the populace, not on sustaining a highly technical resident population. Let's delve into the nature of that workforce because it's central to whether this was an efficiency-driven or a mobilization-driven operation. The evidence clearly shows a structure built around rotational deployment. The laborers who came in for their 2 to 4 month seasonal shifts, they left behind their team marks. Some are recognizable hieroglyphs, others are simple invented signs like pitchforks or cross sticks on the core blocks. This suggests a state mechanism designed to temporarily mobilize a vast cross-section of the populace, likely during the annual agricultural off-season. This highlights the social genius of the administration, their ability to coordinate the labor pool of the entire kingdom, rather than relying purely on sustaining a singular professional permanent city of builders for 2 decades.
I see why you emphasize the rotation and the social contract, but the term rotational doesn't equate to amateur or, disorganized. In fact, the existence of such a rapid turnover of personnel requires an even more sophisticated permanent administrative core just to manage it all. The evidence of specialization is just too great to ignore. Take the support infrastructure. The massive industrial zones, the bakeries, the fish processing complexes that provided the core's sustenance were permanent, specialized installations, highly integrated and managed. You don't build a bakery capable of mass-producing thousands of loaves a day if you only plan to use it for 6 months. Similarly, the highly planned orthogonal layout of the cemeteries, intended as a long-term community of cause for Khufu's court, demonstrates a settled, specialized state apparatus designed to support those short-term, highly focused labor shifts.
Control and personnel on a mass scale. That level of institutional control, well, it required deep, permanent centralization, proving the foundation was built on efficiency, not just raw mobilization.
That's a compelling point about the need for administrative control over resources. I'll grant you that. However, when we look at the physical results of prioritizing that speed 34 blocks set per hour, we see compromises. Centralized control effectively managed the external logistics, but the sheer momentum required led to a simplification of effort in the core construction. The interior core of the massive structure, the vast majority of the stone, often displays what we might call a slop factor. These are large, irregular, loosely packed stones, often filled in with debris and tofla, which is a kind of silty, powdery filler. This evidence suggests that speed and bulk delivery of stone were prioritized over the fine craftsmanship and meticulous fitting we see only on the outer tasing blocks, the ones sourced from Torah. The system, while administered centrally, was geared toward raw production momentum, not uniform technical elegance. If efficiency was the ultimate goal, why the lack of internal finesse?
You point to the physical results of speed, but that result doesn't negate the planning. It simply shows where the planning prioritized precision. The core provided mass, stability, and speed, and that internal irregularity was permissible because the precision was focused on the external geometry, which was paramount to the pyramid's function and durability. The sophisticated engineering of the Great Pyramid proved central planning guided the entire process. The required slope, precisely 51 degrees, 50 minutes, 40 seconds, was set using the Sedgit measurement, a ratio of run over rise, dictating the exact geometric form. This was an advanced surveying technique used from the base up. Furthermore, the search for the center point, the literal heart of the entire construction, was accomplished by using precise distance site reference markers and fixed stone sockets. The ability to raise and sustain immense weight high into the core, evidenced by the 5 stress-relieving chambers above the king's chamber, demonstrates not just brute force but an internal mastery of load distribution and structural dynamics. The execution may have been fast, but the blueprint was entirely controlled by efficiency and advanced engineering.
I'm not convinced that the impressive design details negate the practical struggles of execution. While the design was undeniably precise, the sheer scale meant that the ramp system, the true logistical bottleneck, it must have been far less imposing and structurally robust than ideal theoretical models might suggest. As I mentioned, an ideal ramp would require an unsustainable volume of material, so the builders had to devise a simpler, faster way to elevate 340 blocks daily, possibly using complex spiraling or internal ramp systems that maximize the work area while minimizing the material cost. This speaks to overcoming scale through practical ingenuity and effort, not flawless technical efficiency. We also see clear evidence of adaptive, reactive learning rather than a perfect, pre-planned execution. The fact that royal pyramids like the Bent Pyramid and Khufu's subsequent designs saw major shifts in internal chamber locations, construction methods, and external angles suggests the builders were actively struggling, learning from physical errors, and experimenting on the fly. The design was complex, yes, but the execution was a constant high-stakes battle against physics and scale, driven by the urgency of the king's death date.
But that struggle, as you call it, is precisely what sharpens understanding and leads to more efficient methods. The shift in building methods, for example, moving from the less stable inward-leaning accretion layers of early attempts to the horizontal beds used in the Bent Pyramid and Khufu's final design, that shows calculated adaptation and systematic improvement dictated by a central authority that learned from its massive engineering projects. This is the very definition of process efficiency. Look at the sheer scale of resource extraction that had to be managed daily. The massive local Khufu quarry is visible today, a monumental horseshoe-shaped bight 300 meters long. It demonstrates pre-planning. They knew exactly where the core material was, how much they needed, and they calculated the required daily quarry volume. Researchers estimate this required over 1,200 men working daily just to extract the core stone necessary to feed that 2-minute per block placement rate. Managing the coordination, supply, and movement of those thousands of men from extraction to placement requires a highly centralized, permanent, and efficient administrative state running at maximum capacity for decades.
That permanent administrative structure, which I agree was powerful, existed to serve the king's eternal cult. But if the physical infrastructure that supported the workers was truly permanent and efficiently planned, why did it deteriorate so rapidly once the main construction was complete? If we look at Menkaure's pyramid town, the support structures there, they quickly dissolved. The official cult maintenance structures eventually turned into what archaeologists describe as a sacred slum, where small irregular huts and personal grain silos invaded the original orthogonal temple court layout. This reveals that the support infrastructure was inherently temporary and resource dependent. The massive investment in industrial processing and housing, it just evaporated once the immediate economic catalyst, the construction itself, was finished and the court moved on. The permanence was in the cult, not in the construction town.
But that term, sacred slum, describes the post-construction maintenance phase, which was staffed by a small specialized priesthood. That is a vastly different economic and demographic challenge than the building phase. During the critical 2 decades construction phase, the evidence points overwhelmingly to a massive, highly structured settlement. The existence of thick boundary walls like the 200-meter Wall of the Crow, which served as an imposing gateway, and the documented royal workshops working copper and alabaster integrated near Khafre's complex, shows that the state established a powerful, structured, and functionally permanent center of production. This was not a transient collection of tents, it was a fully managed, state-funded proto-city established to facilitate the construction, a definitive signal of a massive, long-term societal commitment and institutional efficiency.
But the temporary nature of the labor is key.
The state established the centralized administration and built the supply chain systems, the causeways, the bakeries. But the massive daily lifting and setting requirement was met by a rapidly rotating populace, whose primary focus was simple, high-effort delivery. The core of the operation was people power.
And the core of my argument remains that mobilizing and sustaining that volume of high-intensity short-term labor, the flow of thousands of people, the provision of food, the sourcing of tourist stone, and the engineering necessary to ensure the entire structure maintained a perfect 51-degree angle, that cannot be sustained through brute force alone. It required an administrative machine of unparalleled efficiency designed for long-term output. So we've seen that the pyramid builders operated within a sophisticated, centralized system where every resource was meticulously accounted for. The logistical efficiency required to coordinate supply from distant quarries, the high precision achieved through advanced surveying, and the deployment of massive, specialized, and permanent support installations all point to a deliberate, efficient logistical blueprint that allowed the state to sustain the monumental pace required for decades.
Indeed, the organizational achievement was immense. However, the sheer mathematical demand, one block set every 2 minutes, forced the builders to streamline and simplify the technical requirements of the core materials, evidenced by that slop factor masonry. The execution relied heavily on simplified elevation methods and a rapidly rotating, high-intensity labor force mobilized from across the kingdom for focused shifts. The construction was less a marvel of elegant, perfected technology than an overwhelming triumph of social mobilization and the effective application of raw effort and momentum to overcome practical physical constraints.
It is clear that the construction of the Great Pyramids was a complex blend of advanced, meticulous planning and the necessity of managing tremendous scale and speed.
And understanding that tension between the required speed and the capacity of the available technology helps us truly appreciate the deep societal infrastructure that enabled the operation of the living pyramid. There remains much more to explore in the material itself.